Thank you, ladies and gentlemen. We request Honorable Director CRRI to welcome our chief guest, Honorable Director H. Tilani, Professor Sudhir Kumar Barai, by presenting a plan. Thank you, sir. May I request Head Bridge Engineering and Structures Division, Dr. Rajiv Goel, to welcome Mrs. Raychaudhari, wife of late Dr. P. Raychaudhari, by presenting her plan. Thank you, sir. We request Dr. Rajiv Goel to welcome Architect Raychaudhari Raychaudhari, daughter of late Dr. P. Raychaudhari, by presenting her plan. Thank you, sir. Now I will invite Dr. Rajiv Goel, HOD Bridge Engineering and Structures Division, to kickstart the event with his welcome address.
Thank you. My own behalf and on behalf of CSRI welcomes Dr. Barai, Dr. Planning, and Blue River, the lecture today on a very important topic, potential big data analytics in sector health monitoring. For solutions are Dr. CRI, Dr. Raychaudhari, wife of late Dr. P. Raychaudhari, architect Raychaudhari, daughter of late Dr. P. Raychaudhari, other family members of late Dr. P. Raychaudhari, his colleagues and who are joining this event online, Dr. PhD Chief Scientist, CRI, online participants from across India and abroad, and my fellow colleagues from CRI. Sir, CRI was established in 1952 and is establishment of KSIR. In CRI, we have 7 R&D divisions, including Bridge and Engineering and Sector Division. The emphasis of Bridge Division is to carry out work in the following areas: enhancement design of bridges and other engineering sectors, application of advanced components of bridge construction in the rehabilitation, distress aggregates and rehabilitations, bridge maintenance management system, health monitoring of bridges through instrumentation, health assessment and rating of bridges, structural safety audit of bridges, evaluation of load carrying capacity of bridges, formulation of codes and practices and guidelines as part of IRC and BIS, use of waste materials such as fly ash, CND weights, waste acceptance concrete, application of video sensors for health assessment, development of customer drone for inspection of bridges, development robot for underwater inspection of bridges, the practice of various routes for bridge design, coordinate studies in bridge and other sectors, fatigue studies on bridge components, bridge and studies, lab of testing for bridge design and evaluation, vibration studies on bridge and structures, bridge aerodynamics, development software for structural applications, quality assurance during bridge construction, etc. So we have the set of facilities on regions such as structural test laboratory, dynamic of heavy testing laboratory with fatigue testing system, wind tunnel facility, mobile wind inspection unit, field instrumentation facility, and LED facility for complete as well as steel, the axle testing machine for nuclear bearings, and shortly we are going to develop this called facility for testing of defective designs in CRI. Sometime in March 2018, Dr. Raychaudhari approached CRI with a request to start this series in CRI in the memory of our late husband, Dr. P. Raychaudhari. For this, he wanted to create a corporate funding institute, and our director has really agreed our request, and with that, we start this series. First lecture was organized as informed by Dr. Durga on 29 August 2018. He was Professor Raychaudhari gave a talk. It was 19 Professor Tarun Khan from IIT Bombay gave a talk. And last year, for the city, we enabled CEOs to consultant unit top. With this background, I will now briefly introduce late Dr. P. Raychaudhari. He was born in Bogara, which is present in Bangladesh, on June 20, 1932. He completed his schooling in Calcutta and obtained BSc Honours Physics in 1951. He did BTech in 1955 and MTech in September 1956 from IIT. He joined CRI in 1957 as Senior Scientific Officer in Cognitive Division. He received the President of Commonwealth Scholarship and completed PhD from University of Leeds, UK in 1964. After completing his PhD, he joined the CRI to the Big Division, which was under the charge of Sri P.K. Sri Raychaudhari was the first full head of the Big Division who developed the state-of-art infrastructure in the division with dedication and innovation, with assistance of optimal staff, and made it the center of excellence in the area of condition survey, testing, and evaluation of bridges. His other area of research includes bearings, spin joints, well foundation, retaining walls, rigid pavements, space rings, etc. He was given the additional charge of CRI workshop and CRI mine works of quarter and the area group, and he was the area coordinator for the rigid pavement regions to be given from 1986 to 1988. He rose to position of scientist as before taking BRS in 1988. Out of his 31 years service in CRI, he worked on 4 years as a head of the division. He was associated with reputed firms such as a secretary consultant or advisor on various projects of national interest till his demise on 24th August 2016. Some of the major contributions in CRI are as follows: the annual construction of test bed for strong test load laboratory in division, commissioning of right cell loading machine for testing of bearings, development of installation of suspension biometers for detection measurement for the doing load test, development and utilization of long-length gauge for string measurements, development and utilization of underside pulling technique for load testing of bridges, large mobile test bed for PED division, commissioning of NSC UTM for PED division. Some of the major federal funding projects handled by him are Condition Survey of Yemen Setu, Calcutta, ITO Bridge, New Delhi, First Hanik Bridge, Bombay, Ramjan Bridge, Bihar. Condition Survey Road testing of Turkish Bridge near Jawad Tunnel, Jammu, Submarine Supply for New Delhi, Howrah Bridge, Calcutta, Jodhpur Bridge, Assam. Second consultancy for post-checking and execution of Indira Gandhi Indoor Stadium, New Delhi. Condition Survey of Swiss Joint Promotion Flyover. He was fellow of many professional bodies, including of engineers. He was also associated with several technical committees of IRC and various forms and boards. And he was called by his colleagues as Mokuda to his highway. He was very good in the dramatics, was fond of outdoor games such as football, cricket, hockey, etc. He also liked indoor games like carom and bridges. Thanks. Thanks, Jackie.
Thank you, sir, for briefing about this lecture series and to introduce the gathering with the contributions made by Dr. P. Raychaudhari. Now I request Sri Devjani Raychaudhari for enlightening us with some insights about our father, late Dr. P. Raychaudhari. I'm sure that will act as a source of inspiration to all of us. Ms. Devjani ji, please.
Good morning, everybody. I would like to thank the director, CRI, and everybody in the Bridges Division for permitting and organizing the 4th Memorial Lecture Series in the name of my father, Dr. P. Raychaudhari, even under these unparalleled circumstances. We as a family realize this is a great privilege to have the series in CRI in the memory of a scientist who worked here. I'm not sure how many of you in the audience have had the opportunity to meet him. He joined Central Road Research Institute as a senior scientific officer after his graduation. My father joined CRRI as a senior scientific officer in after his graduation and post-graduation from IIT Kharagpur. In Kharagpur, he was described as a brilliant, jovial fellow. My dad was very modest and did not desire for any awards or honors. So this lecture series in his name is a big honor for him. So thank you for that. He was personally very happy that he had the unique distinction of standing first in the order of merit for the first ever examination conducted by the first IIT in India, that is Kharagpur. After that, he did not need any awards or accolades. However, while at CRRI, he obtained the prestigious Commonwealth Scholarship in UK and obtained a doctorate degree from Leeds University in 1964. He also taught at the Imperial College London. He continued with CRRI at different levels with specialization in bridges till he took voluntary retirement in 1988. After that, he was actively associated with several leading structural and bridge organizations as a consultant, specializing in bridge repair works. He continued working actively till the age of 84, till he passed away 5 years back. My father was gifted with great intellectual tenacity and believed in systematic applications of the first principles to all problems, and solving structural issues was his forte. He was equally at ease to help my mother to get her PhD in biology. Her mentor joked that he deserved half a PhD. He was interested in knowledge for knowledge's sake. He was excellent in analyzing data and discovering hidden patterns and their correlation. He would have been greatly interested in today's lecture on the potential of big data analytics on structural health, that being one of his favorite subjects. People enjoyed his warmth, hospitality, and sense of humor. He was a witty conversationalist. My father was very fond of youngsters and they of him. It was not surprising to have 8 to 10 enthusiastic young engineers at home for a meal prepared by him. He always remembered to get chocolates from his trips abroad for them. He was very actively involved in organizing many functions at the CRRI campus at Maharani Bagh when we lived there. This lecture series has been a great learning experience for us about his work life. We got a wonderful message from the retired Deputy Director of CRI, Dr. Sunil Bose, after the webinar last year, which was graciously forwarded by many members here at the Bridges Division. I want to share parts of the email here. It described his work style and his personality very well. Quote, Dr. Raychaudhari was from my IIT. Certain aspects you don't know about him, he was a brilliant engineer. First time I saw him in the FP division was with his hands full of grease and he was repairing the UTM or the Universal Testing Machine himself. I found he was speaking in flawless English. I wondered and thought, this mechanic speaks excellent English. Later, somebody told me and introduced me to him and said he's one of the senior scientists at CRI and a PhD from Leeds. I was shell-shocked. But what shocked me the most was his humility. He would freely come and ask for cigarettes and tea. But during these visits, he would technically teach us a lot of things. We always looked forward to his technical ideas. After his retirement, I worked with him for a CRRI project, the design of pavement for a 375-ton crane to lift the nuclear reactor at Bombay for phases 3 and 4. I designed a flexible pavement and he handled the concrete pavement. Those days, no design method was readily available. According to my personal view, he was one of the most brilliant scientists we ever had. You must know that his father was conferred the Palak Professor at Physics at Calcutta University when Meghnad Saha and Satyan Bose were around. He would never boast about anything, unquote. Such a wonderful tribute. Thank you, CRI, and thank you to Bridges Division, all of you, for this wonderful opportunity for this knowledge series.
Thank you so much, ma'am, for sharing the wonderful memories of Dr. P. Raychaudhari. Now I invite Honorable Director CRI, Professor Satish Chandraji, for his address, who has been a continuous source of inspiration and guidance to all of us in organizing this event. I request you, sir, to address the gathering with your encouragement.
Thank you. Professor Raychaudhari, architect, Raychaudhari, Raji, Dr. Lakshmi, and my friends. I know Dr. Barai from 2008 when we were in a team of organizing GATE. And I was the member of that team from IIT Roorkee, and he was a member of the team from IIT Kanpur. Those 2 years, 2008, 2010, were really memorable because we had a lot of fun, a lot of work, a lot of new ideas introduced in the GATE. And that was the time when, first time, the online GATE was introduced. And we had a lot of discussion with that private players who were involved in organizing GATE online. I came to know that he is now Director Brispilani only this year, in the month of, I think, January, when he sent a New Year message to me. It was really very heartening to know that he has occupied that chair of Director Brispilani, where earlier Dr. K.K. Sarkar was holding that position. I welcome Dr. Sudhir Barai to CRI. Probably this is his first visit. And Dr. Rajiv Goel was telling that the institute was set up in 1952 and Bridge Division was made in 1962. Other than Bridge Division, we have 6 more R&D divisions in the institute. We have 3 divisions which are fully dedicated to payment research. One division on flexible payment, another on rigid payment, and the third on payment evaluation. And their basic focus of research nowadays is, although you will have a visit of different labs in CRI in the afternoon, but just giving you overview of the divisions that this focus of payment research nowadays is to make use of alternate materials in road construction, particularly for making our road infrastructure sustainable. Use of waste, use of new materials, use of plastic, and many more. Even recycling of payment is the focus area of research nowadays in CRI. And mandate of CRI is to not only to do fundamental research, but on applied research. And therefore, whatever these divisions are doing, directly going into IRC codes. So all IRC codes which you find related to payments or in bridge or in traffic, the major part of research come out from CRI. Then we have a geotechnical division. Their main research area, or you can say study area, is landslides, mitigations, use of waste material in embankment, and also ground improvement techniques. 2 more divisions, that is traffic engineering and safety and transport planning environment. They are involved in research in planning, in engineering, and in safety, also in environment. So mobility, CRI was probably the first institute in the country to introduce the comprehensive mobility plan for a city. And we did these plans, we prepared these plans for several cities in India, and even today our scientists in Surat to have a meeting with the Surat Municipal Corporation for developing some flyover underpass on 3 corridors in Surat City. They have very good expertise in road safety, and we have conducted road safety audit of several thousands of kilometers of national highway and state highways in the country. Road safety, as you might be say now, great problem of the country, not only the country but the world over. And Ministry of Road Transport and Highways is also worried about it. CRI has signed an MOU with Ministry of Road Transport and Highways for conducting training programs on road safety. So we are creating road safety auditors in the country so that they can make our highways safer. In environment, their main focus is on driving cycles of the vehicle, how emissions basically come out, or what are the kinds of emissions coming out of the vehicle and how they can be reduced. Recently, we conducted one study which was sponsored by PCRA, where we found the idling loss, fuel loss you can say, and the vehicles are standing behind the stop line at single round intersection during red light. And we studied some 100 intersections in Delhi. And I should tell you that there are about 954, maybe 1,000 intersections in Delhi. And what we found that at these 100 intersections, the total loss is around 1.7 crore per day. That is the kind of fuel we are burning at single control intersections. And the slogan which was given by our scientists is that if red light is more than 20 seconds, switch off the engine. So this is the, you can say, spectrum of activities being done in CRI, and I'm sure you will, when you go around the laboratories, you will realize that we have very state-of-the-art facilities in all labs and doing, if not world-class, but at least one of its kind in India kind of research. With these words, I again welcome you all to this lecture, and my special welcome to Dr. Sudhir Barai, who has kindly agreed to come over here from Pilani to deliver this talk. Thank you very much.
Thank you so much, sir, for explaining and introducing our different divisions of CRI and explaining about the achievements of the institute to the entire institute. Now it is the time for which we all have been eagerly waiting for. Without taking much of time, I would like to introduce our chief guest and esteemed speaker of the event, Professor Sudhir Kumar Barai. He is a director and senior professor of civil engineering at BITS Pilani, Rajasthan. He is also a professor in the Department of Civil Engineering, Indian Institute of Technology, Kharagpur, availing leave for the current position. In 1995, he obtained PhD from Indian Institute of Science, Bangalore. He received the degrees of BE Civil and ME Civil with specialization in structural engineering in 1987 and 1989 from the Faculty of Engineering, MS University of Baroda. He was Esquire Visiting Fellow at University of Canterbury, Christchurch, New Zealand during the May to June 2008. He was also a visiting scientist at National University of Singapore during May to July 2003. He was recipient of Voice Cast Fellowship and visited Department of Civil and Environmental Engineering, Carnegie Mellon University, Pittsburgh, USA during May to November 2000. He was a postdoctoral fellow at Department of Solid Mechanics, Materials and Structures, Tel Aviv University, Tel Aviv, Israel during February 1997 to July 1998. He was published more than 230 plus papers in leading international journals and conferences in his research fields. He has co-authored 3 books, Concrete Fracture Models and Applications, Shear Strengthening of T-beams with GFRT, a systematic approach, and systematic approach of characterization and behavior of recycled aggregate concrete, which have been published by Springer. This was just a brief introduction about him, lots of achievements, a lot of accomplishment to his credit. We once again thank you, sir, for accepting our invitation and gracing this event with your presence. Now we request you to kindly deliver your talk on the topic potential of big data analytics in structural health monitoring. As a protocol, I would request all the attendees who are attending from the MS Teams and the YouTube Live who are participating in the lecture can post the questions in the chat box, which we will try to take up during the question and answer session if the time permits. Now the floor is yours, sir. Over to you. Thank you. I request all the dignitaries to come down so that it will be. A very good morning to all of you. Professor Satish Chandra, Director of CRI, Dr. Minati Raychaudhari, Architecture Raychaudhari Raychaudhari, Dr. Rashmi Pamitra, and my host, Dr. Rajiv Goel, and all the scientists and all the audience who are here and outside. It's indeed a great pleasure to be here for the 4th P. Raychaudhari Memorial Lecture. After hearing about Professor Raychaudhari, let me say I felt very proud about listening about him for multiple reasons. First of all, he is a graduate of an early batch, possibly of IIT Kharagpur, maybe the first batch possibly. So he's a pioneer batch of IIT Kharagpur. My association with IIT Kharagpur has been for 21 years. I'm currently a BN from Kharagpur to IIT, Wits Pilani. So that is something which we feel very proud about our alumni. So naturally, I think Dr. Raychaudhari has really made a big name for himself, for the institution, and his contribution, the way he has set up the various activities at CRR. The second thing is that when he joined this institute in 1964, if I'm correct, after his PhD at Leeds, possibly that year I was born. So, so that is something which is another connection that when he was kind of leading the whole this group in this Premier Institute, I was just born, maybe possibly, and today I think the cycle is like completing, and I'm kind of standing here to deliver the lecture in his memory. And that too particularly after like 3 legendary speakers before me who gave these talks of Mr. Tandon, Professor Tarun Khan, and Mr. Hegde, and now I'm here. I think there is a whole sense of responsibility there on my shoulder actually. I do not know how I will come up to that expectations of being the speaker today. But whatever I have learned during my career in the civil engineering domain and the kind of a work which I've been doing, I try to put the things together. In recent times, there is a lot of discussion about machine learning, AI, IoT, blockchain, and a lot of these buzzwords are going around data science, big data, and so on. 1989, when I joined for my PhD at ISC Bangalore, I never knew that there is something called artificial intelligence. Okay, and I had to decide my PhD topic for research, and I went to my supervisor and I asked that what the research topic would be. And then he told me that, were you interested in working artificial intelligence? I did not know what is artificial. I was at least aware about the natural intelligence, but I did not know about it. So I had the fortune of talking to computer science students, and then they told that artificial intelligence is a big thing. It's something which is very interesting area and all that. But I don't know what civil engineer guys are going to do with that. So I said, then it makes sense that kind of create the hybridization of the state-of-the-art knowledge of a computer science and bringing into the civil engineering. And that is how I ended up doing my PhD in using artificial intelligence and neural networks into the beach damage and assessment. And that was a thesis, which was kind of, you can say, the early stage of the thesis in India, which worked in this domain. So that kind of a review I got it from my thesis.
Again, there is a story. Professor Satish Chandra mentioned to me that this might be my first visit. This is a formal first visit. My zero visit was, I came to this campus, I was in the same corridor where your conference room is there. I was interviewed for the scientist C post for SCRC Ghaziabad. And that time SCRC Ghaziabad was headed by Professor Ian Tricard, was the director. And he was incidentally my thesis examiner. And he had told me that why don't you just apply for a scientist post in CSI or SCRC. And that is how I came. So it looked very familiar. Of course, the glass panels have come, looks more sophisticated, much better than what I saw in 1996. So almost like 20 years. So anyway, so recalling this one, it was like a kind of a feeling. It is very exciting, and I felt really good coming here. So anyway, so it's a pleasure for sharing the little knowledge what I have in the domain of this data analytics. As you can see, what I intend to do in next less than 40 minutes or so, to kind of combine both the things together, what is being the recent times that people are talking about big data analytics and how the structural health monitoring has a relevance to in the present context. So to give you a little the outline, is that I will give you a little background about it, what is actually the structural health monitoring, what are the advantages of it. I know most of the people in the bridge division here must be knowing about what is this structural health monitoring. So, but I'm just trying to kind of be on the same page and then try to kind of connect it with that why it is so important and how the big data analytics can play an important role. And then I'll just briefly talk about the big data analytics part of it. Then we will connect these two things together, like how the big data analytics plays in structural health monitoring, and I'll close it with my remarks. Okay. So in terms of the background, first let us define what is actually the health monitoring or structural health monitoring. So it is nothing but it is basically, let us assume there is a system, and there is on a system there is an input forces or the external force is acting, and the system is responding to it. So that is what we call as an output. So there is an input and there is an output and there is a structural system. So what we are looking at is that given under the situations, if we kind of operating all the loading conditions which will be there around the system, if the system is going to respond correctly, then we say the system is in a good health. But if system is going to respond a little unusually, then we share. Where is the presentation? Sorry for the interruption. I think that was a time sharing, sorry, the slide sharing with the MST. Okay, so what we were mentioning about the system, and there is an input and there is an output, and we want to kind of identify what is going to be the situation. So I just want to give a little parallel example, like a human health. Basically, what we say is that in a human health, generally we try to see that an individual that goes for the health checkups. Then the preventive intervention is done, and the surgery or the recovery process is suggested, and that is how we do that. So that same parallelism can be applied for the infrastructural systems as well. So there is also the when you put the structural system into service over the period of time you monitor it, and if there is a maintenance required, and you do the repair or retrofit and kind of extend the life of the structure. So this is an analogy which I always try to give that the people try to understand what is actually structural health monitoring. So this is something which we do it in terms of analogy. Now, whenever we are doing this, the health monitoring, there are basic steps which has to be followed. So the first and foremost thing is that there are 4 levels. The first level is that what is the existence of the damage. That itself is the first question one need to ask. Then is there any damage into the system? And that is, if there is a presence of a damage, that is a level 1. Once you identify that there is a damage, then you go to the level 2 and then try to find out if there is a damage in which location it is. So which place it is happening. So that is what we call a geometric location at which it is happening. That's the level 2. Then we go to the level 3. Once you identify the existence of a damage in the location, then we try to find out what is the extent, how much the damage has occurred. So that is the level 3. And after that, once you have an assessment, location and the extent of the damage, then you will be able to find out what is going to be the remaining service life of the structure and what are the retrofitting things can be done so that we can extend extend the life of the structure. So these are the very common steps which are followed typically in a damage identification. Now, when do we should do this one? There are different ways of kind of assessing the damage into the structure. One is that what we call is the response record point of view. That's more of a quantitative. Another side is the qualitative. That is what we call as a visual. And we try to kind of assess the situation of a structure at the localized level, at the cumulative level, and finally overall structural level, so that we should be able to assimilate. So that is where now the situation comes. That there is a piece of information which is qualitative, the piece of information is quantitative, we need to merge them together and finally arrive at a conclusion and look at the health of the system. So that is what we call damage index definition. So these are the different terms. I will not get into the details of it, but just to make you aware about it, that let's say for example, an individual goes to the doctor, initially he will ask you the symptoms, and based on the symptoms he will try to ask you certain questions. That would be a general qualitative assessment of a doctor. Then he prescribes some of the tests. Those tests are quantitative tests, and that is how you kind of get that information. He merges two things together, and finally he arrives to a conclusion. So this is what exactly we do in the structural health monitoring as well. Now, what are the advantages? The advantages are many. And I was listening to Dr. Goel, and he was mentioning about a lot of things which has been done at the British division, where some of the learnings which has happened in the field, how it is getting codified, how the code of practices are defined, and so on. That is one of the major advantage of doing the structural health monitoring. So we can build the database of the built-up structures, because every structure is very, very unique. Every structure which we create is actually different than everything. Like unless and until there are the preset kind of configurations, and we manufacture in the factories, and then you take it to the site and assemble them, that's one part. But there are many structures which we create, large number of structures which would be unique by itself, because the material would be different, the fabrication method would be different, executions would be different, the purpose would be different, and so on. So we need to really build a database, and that is what it helps from that. The other thing is, of course, improving the course of practice. We actually become better by creating a performance-based engineering, and that is where actually the health monitoring helps us. The other thing is that renewal engineering means in terms of how we really extend the life of the bridges and so on. So now in India, let's say large number of bridges are there, but there are many bridges which are 100 years old. So now we can imagine the bridges which have been built 100 years back, still in a present condition, and the traffic and the movement, still they are functioning. So maybe people can say it was over-designed or whatever it may be, but today when you see that, the performance still, and that is why if you want to extend the life of the structure instead of just demolishing them and creating a new structure, it's better to do a renewal part of it. So how do we really use that? And of course, that needs the innovations, and of course the operational and management systems, and of course the on top of it, that we will have to handle the emergencies as well. In terms of the life cycle, basically every government goes through a very difficult phase. There are large number of bridges are there. We need to really kind of have a database of all bridges. Then you go to each bridge, the structural component part of it, and then you go to the sub-component part of it. You assess the whole the elemental level understanding of the bridges, and then finally actually you create the assessment of that bridge. And you can prioritize based on the condition of the bridges, that okay, in this particular locality, the 10 bridges are there, which bridge has to be taken first for the maintenance, because that priority is also important. Funds are limited. You need to assess that, okay, this is expected life of the next bridge is 5 years, other one is a 1 year. So maybe possibly you have to invest more money on a 1 year life, because you have to kind of invest the money there. So this is where the SHM also can help you with the continuous. Now, since the advancement of the computing, since the advancement of this, the sensors, the kind of the facilities available, this has become all the more important for us and how we really optimize it in a different way. The moment we talk about this monitoring the structure in a real time using these advanced technologies and sensors, the most important thing is that what are the utilities and what we can do that. All right. So this brings in other set of parameters for us. The most important thing is that we need to acquire the data. Okay. And acquiring data is basically is done with certain purpose. So you have a large number of data, a large set of database. This database actually you are extracting an important information, and from that information you are extracting the knowledge, and that knowledge is going to be used for your decision making. So you need to understand that data is not the final decision making. Data is just acquired, it has been just gathered, but you have to assess it, you have to extract the information out of it, and that information becomes a knowledge for you, and that knowledge will help you to take a decision. So that is one of the reasons, whenever we want to do the real-time monitoring, we need to understand that from what source we are collecting the data, how we are actually going to use it for the final utility point of view. So one is the data acquisition, the data transmission, you are transmitting the data from location, how you are going to store the data, what is the analysis of the data, and finally visualize it. So I will give you in one picture only. So if you look at this picture very carefully, the first picture shows the more about the data acquisition part of it. It means that the bridge is there, the bridge is put up with a lot of sensors on that, and there is a communication is happening between the bridge's data getting transferred to the local wireless sent to your local data server, and from there it goes again transmitted to the remote server, and again that will get analyzed by the end user. So in the process of this whole exercise of from data acquisition, data transferring, data processing and everything, every stage there is a challenge. Now people will say, as a civil engineer, do I get myself restricted to the left-hand side block, or I should get into the everything? Let me just tell you, we are to the stage where we need to kind of get acquainted with everything. We now must understand all the technology. It's not necessary that you should have a mastery in learning about all the sensors. There's the electronics engineer, they can possibly give you the insight. But it is very important from a civil engineering point of view that which are the locations I'm going to put the sensor, what is going to be the sensitivity of the sensors, how many numbers of sensors I'm going to put, what kind of information I'm going to gather, that information at the last block, I'm going to use it for analysis purpose, and then finally making the decision. So all these phases where the civil engineer plays a very, very important role. It looks very nice and simple and very elegant, but when it comes to implementation, that's the most challenging part of it. And one of the most important thing is that whenever the data is acquired and sent out by the transmission, there are a lot of other issues will come. The kind of technologies we are using in the wireless or wired, both the ways, there will be noise, there will be sensors, challenges will be there. How many are working? How do we really find out the cross correlation between working sensor and non-working sensor with the reality and so on? All these challenges will come, which we have to kind of address that. So this is the real-time issues. Now, the moment we are talking about in a one single bridge this, imagine all the bridges are monitored. We are talking about the smart cities. We are building up the smart townships, smart infrastructure. Everywhere, if you start putting up the sensors, the data, the amount of data which will be generated would be huge. Somewhere it is said that every second we generate around 1.7 megabytes data. So by the time my lecture gets over, I do not know how many gigabytes of data we have generated. Okay, and this is what the speed at which we are generating the data. So what we are trying to say that this kind of sensors and the network will generate a huge amount of data for us, and that is where the data analytics comes into picture. And particularly looking at the previous picture, at every stage there is going to be the. I will give you the case study, and you will understand that in one single bridge, how many sensors you put in and what kind of data which you will be generating. That itself becomes a challenging thing from a monitoring point of view. So now let us understand from the big data point of view. So the big data is actually nothing but the scale, the diversity, the complexity. It requires a new kind of architecture. And I mean, architecture is not the architecture, they've done the architecture, but it's a hardware architecture which I talk about, the kind of a hardware which is required, how it is going to manage, how do you deal with the techniques, how do you do the algorithms you apply so that the faster way you can really analyze them and finally you can allow come out with a very interesting information which is hidden. And there's a very interesting domain now in knowledge discovery and data mining where heaps of the data is available and you are trying to find out the golden nuggets in that information. And that golden nugget is nothing but it is what we call is the knowledge. And that is what the most important part about the big data. Now in terms of the big data techniques, there are many stages. At every stage you can use it. And the challenges I mentioned about it, the one is the data acquisition. How do you really acquire the data? What is the ways you are going to kind of acquire the data? Internet of the things. Now everybody is using this drones and Internet of the things and so on. People are actually using a different technology through which the data is acquired in different form. So these are the acquisitions ways. There also again we have to learn how to really optimize uses of data. Next one is the data storage. How we are going to store them, and the data computing is one another domain. How are we going to use this data for computation purpose, and of course the analysis part of it, which is nothing but knowledge discovering, or you're talking about the machine learning and the deep learning, or what we call about today's time pattern recognition and statistics. So the big data techniques will help you to kind of come out with the conclusions. Now, to understand the big data point of view, I'm going to put across to 3 or 4 different things. So one is that what we call is that the scale, or we call it the volume. So the data volume, like you can just see that from 2009 to 2020, 44 times the data has increased now in terms of the number of data points and all that. So one challenge which is we have to address is the volume of the data. Many times all the data is available in the hard disk, but we don't know what to do with that. Okay, so we need to understand that whatever is important, that only we are going to be using. We don't want to use all the data sets. So that is why we call this a volume. That is the one part. The second is the what we call is a variety. So with different kind of a varieties, the complexity would be there in the data. The data could be in different form. It could be text, it could be numerical, it could be images, it could be video, it could be audio, it could be any different forms. And now all this data of a different complexity is coming together to us, and we need to take a decision. So that becomes all the more again interesting. I can just give you a little very, you might be thinking that how this kind of a thing can happen for a breach health monitoring, let's say for example. So nowadays, very interesting thing, like putting sensor is very common, putting videos on cameras on the breach is very common, everybody acquires the data, but there are now these wearable computer circle, so people can wear on the body, and the person can go to the breach inspector, can go to the site, and he looks at the breach. He has a mounted camera on it. Localized pictures are taken by his camera there, and not only that, because it has to have a hands-free location, so he doesn't take a diary. So he's now recording it. Okay, I'm on a particular member, on a particular location. This is an image of it. This is the condition. This is my observation. Now that is a speech. So you have images coming in. You have the speech coming in. You have the physical data coming in, you have the video cameras put on there. All this information increases a lot of complexity. And that is where the understanding of this big data is very important. Now the third one is what we call the velocity, the speed at which the data is coming. So you can understand that the volume, there is a variety, and there is now velocity. And this velocity is so fast that, as I mentioned to you, just in at 1.7 megabytes per second. And that is the speed at which we are creating the data. Now, if we are having so much of the data coming in, we need to now have a mechanism in place which can handle all these things in one go. To add further, actually, after beyond these 3 V's, now one more V has come. That is what we are calling the veracity. It means that if the information is correct, is there any missing information into that? That also again actually brings the new challenge for it. It's an uncertainty, basically, like in the data. So apart from a volume, a variety, and the velocity, now veracity also is coming into picture. And this is something which is also another important part of it, because we need to kind of find out whether the information coming is correct or not. All right, and that is where these 4 V's we have to use it for our structural health monitoring. Now, who are the people generating? To just give you a little idea. One is the social media, very huge data is created every day. Scientific instruments, all right, mobile devices, sensor technologies, and so on. Everywhere now, wherever there is a sensor, people are creating and all that. The other day, actually, I'm not very savvy about technology, but somebody mentioned about this Alexa. All right, she's monitoring you all the time, what you're talking, what you're having your conversations, and all that. Very smart, and it's an AI driven, totally. So you do not know what you're conversing in the house. Maybe you're hatching some conspiracy and all that. Maybe Alexa may tell you, kind of, and that kind of data would be captured by the machine, and possibly somebody else will come. Alexa, can you tell what these guys are talking? And possibly might be revealing your story, and that is something can happen. So what I'm trying to say, these are the sensors which is kind of gathering information all the time. The other things from this is a recent survey from the Finance Online. They say how much data we are generating every day, like in terms of the numbers. And the most important point is the second one. In 2021, we generated almost 74 gigabytes. By 2024, will be 149. That's a new one. Okay, now the speed at which the data is increasing. And what is going to happen, unless and until you have powerful computers, unless and until you have powerful algorithms, you would not be able to use this data. It will be just lying idle. It will be just useless. And that is where actually now it plays a very important role. I'll share a very interesting story. There was the cafeteria which was opened in IIT Kharagpur, which was opened by the Japanese people. Okay, and this cafeteria you get a free cup of coffee, 3 cups of coffee every day free, either coffee or a juice. You get free for students and the faculty members. Anytime you walk into that, and it is served by the Japanese host there. They would give you. So what you have to do is that you have to just get registered with them, and it was named called Shiru Cafe. You can just search that name and you can find out. And you just have the code will be there. You just take it. So I asked one day the student. I said that it is a free of cost, isn't it? They say yes, it is free of cost, sir. But it costs you a lot. I said what? What it costs you a lot? What is the data? So they ask certain questions, some of the things before they give you free cup of coffee. And the guy who will come to you to serve the coffee, he will tell you about the company, he will tell you about many things and all that. And then it says in turn you might even get internships out of it. And that was a very interesting model they have developed. And they have opened not only one campus, in India there are 4 or 5 campuses, there is coffee shops they opened up. Now because of pandemic it is closed. But this was a very unique model, and that is what I'm trying to say. The data will be sold. Every piece of information will be used by people. And that is where the data is now money, what everyone's talking about. But unless and until it is used. So basically what people say, data is useful unless and until it is harvested. If it's not harvested, it is wasted. And that is where the important thing. So anyway, I just wanted to tell you the kind of data which is getting generated. And in terms of the challenges, because as a civil engineer, we are going to have this challenge because a large amount of this data is created through our structural health monitorings and so on. The most important thing is the lack of softwares. That's a very, very important issue. Another is the lack of analytical skill. People need to understand about how to really analyze the data. And it is a very interesting conglomeration of, or rather the utility of the machine learning, the statistics, the database, the knowledge discovery. All these things come together, and that is how we can use it. So you need to get equipped with this one. That is why the analytical scale will come into picture. Insufficient budget, definitely the budget plays a very important role, and only 11% people are using currently this big data challenge. So one of the most bottleneck I mentioned in architecture, the algorithms, and the techniques which are required, which is not so easily available because things are changing very, very rapidly. Now, in terms of the technology landscape, this gives you broadly an idea in terms of what are the different apps are available, different softwares are available, different platforms are available. But we need to move very fast. Particularly in the area of structural health monitoring, our data in motion is the most critical because real-time data is coming very fast. So we need to have the algorithms and the systems in place which should be able to kind of acquire the data, process it very quickly, and give us the insight about it. And that is where this big data landscape can help. That what are the technology we can pick it up and then use it. Okay, so now we once explained about the health monitoring, data analytics. How do we now combine them together? And let's try to see how one can really use it. Though it is visibly, it will not be very clear, but I can just wanted to give you a little idea that the various researchers, like in recent times, they have tried to use this big data analytics in the health monitoring and various kinds of technology in a bits and pieces people have used it. There is no standard guideline, like one part of the things people do and then they solve it. Otherwise, you need to kind of have a very integrated solution, start till end. And that is something which we need to really develop. If suppose we develop that kind of solution strategies, there is a great potential there. So in terms of this technologies, you need to like building the big data-oriented SHMs, or how do we really kind of solve the bottlenecks, some of the bottlenecks which I talked about for the computing ability. Now, there are certain important things in the data analytics in SHM is that data processing, the data integrations, feature engineering, the pattern recognition, and the last one is the data visualization. The first is the data pre-processing. Once the data comes in a multiple form, qualitative, quantitative, how we are going to process it, how the different kinds of noise you are going to handle it, and so on. Then comes the integration part. How do we really combine them together? And then instead of using the complete data, you try to use only certain features of the data. You are not interested in all the data to be used. Some critical piece of information only you. So it's like, for example, in a criminal investigations when it is done, if suppose the some place a murder has happened and if suppose the police is inquiring with the individual as an eyewitness, it doesn't get into the full physical description. It goes into a very special features. What is the height, what is the color, what is the hair color, etc. So basic features. This is where actually the feature engineering comes into picture. Rather than getting into more details about the numbers, you get into more into the features. And then you try to find out the patterns from there, and then you finally analyze it and come out with a basic solution. So that is what we call data visualization. Here is from the features point of view, there are many ways from the health monitoring point of view. Features are there, like a frequency domain features, time frequency domain, statistical features, mechanics features, so on. So different kinds of features could be there, which you can pick it up from the data and use it for the certain purposes for which we want to analyze. And that is how these features can help us to reduce the size of the problem. I'm sure all of you must have heard about what we call principal component analysis. It is nothing but the kind of instead of having a large data, you just try to kind of work principal components to extract the eigenvalues from there, and then you try to kind of use it for the analysis purpose. So this is kind of a techniques one can use it from health monitoring point of view, the extraction of features. The techniques which we use it in big data analytics, particularly from the breach. What are the different information? The specific example would be the breach properties. What are the visual inspection data available? What kind of sensor has been put? Vehicle load impact, how much is there on that? Structural analysis from using finite element, so on. Management matrices and all that. So all this information you are actually acquiring it, analyzing it, and putting into our integration stage. You are analyzing it, and finally you are making a presentation about the breach assessment. So my intention to give you this overview is that these are the different things which are very, very essential. Many times we say that, oh, it is very obvious. It's not obvious actually. These are the things, unless and until you put them together, you will not be able to understand that what we are supposed to do step by step. And these are the things which will help you to put them in the proper perspective. I'll just give you a little case studies, some of the case studies, and to get you an idea about it. So there is in 2013, actually, Karen Kiburu, and they did a very interesting work on a Vincent Thomas breach. 3 terabytes of the data per year is generating that. Now you can just imagine, okay, that the kind of the data which is generated, if you open a 2 GB file in your Excel, after that you will not be able to save the data. Okay, maximum up to 4 GB you can go, and after that what happens? So now imagine you have 3 terabytes of the data. You need a software which can open that data for you. You are having a data, but you can't even open it. You can't even visualize it. And that is where actually, so these are the things which is going to play a very important role. Another example is the 300 GB acoustic emission data which is created for just for 6 months data. 7 GB data samples per day. So you can see over the year how many terabytes data will be created. Over 20 GB data is created by the automated railway inspection city of this lockdown in Massachusetts. So there are examples where the breach monitoring is happening. The data is generated, but how effectively we can use this data, that itself is a challenging part. And since I know that there are so many projects going on in CRRI, and I'm sure they also must be collecting a large amount of data and so on, it's very interesting that there is a kind of a nice collaboration which can happen with the computer scientists along with the, and of course the statisticians, the maths people coming together and joining hands together to do this kind of analysis will be very, very interesting. So this is something where I feel that I should share some of the case study. I'll share some of the case study in more little detail. So the first case study is at glance, which is again done somewhere in Canada. So it is again the same way. The structure which shows here, it says that there's the different kinds of the trains go, different sensors acquire the data, they are kind of taken, they are integrated on internet, analyze it, and then finally you take a decision that what is going to be the. So this is the whole integrated system is kind of developed as a case study. The second example is that using the different kinds of sensors, what kind of structural configuration would be there, and also combining with the weather and the other traffic conditions. Because these are very important for the bridges in terms of what sensors have been put, whether they're accelerometers or displacements or strain, or are you measuring temperature, the humidities, and so on. All these sensors which you put into the bridge, all this data when it comes, then you extract the features, and then there are now deep learning models are available, which actually takes you to the more insightful analysis about the clustering classifications, and then you can say whether the bridges are safe or unsafe, and then of course based on that you can find out the expectancy of the bridge. So this is something which is also very, very common nowadays to apply into the bridges. As I mentioned, the structural configurations are unique. The supporting information which comes, they are different. The sensory data which is available, they are different. And how do you use the technology? So like in this case, they are using the Hadoop. Actually, it is a technology which was used for developing the solution. And of course, the main idea was to find out the health of the bridge. Okay, so this is again the features which are what kind of features we use it. Structural dynamics features, environmental conditions feature, accessories features, like in terms of age, what kind of the budget is available, maintenance is cost, what is available to you, and so on. So these are all different things can come into picture while you want to kind of assess the condition of the bridge. Here is the another example which is like basically in the same case study, that what kind of different other things can come into bridge, like load effect, resistance gauge, hyperspectral cameras, moisture meters, combine them, find out the reliability index and crack sizes or density, and of course finally the original sensory data which will help you do the deep learning enabled solution. Now these are the cases which are often abroad. Okay. Now let me just take you to the famous case, like you know that is this. We have this cable stayed bridge which is across the Yamuna River, Wazirabad. And this particular bridge is also a very interesting example. Many times people say that why do we have to go for monitoring the bridge which is new? Okay, and as good as like we go through our executive checkups, even though we are perfectly fit, but still we go for executive checkups to make sure that our all health parameters are all right. So keeping that perspective in mind, this bridge at the construction level itself, they have to kind of install with the kind of bridges which are available. So it is very interesting in terms of just the basic data that total length is around 675 meters, main span is around 251 meters, and it's a steel concrete composite deck. Total width is around 35.2, and 4 lanes are there on the traffic. And since it's a main bridge, Delhi based, lot of traffic flow movement. The way it is speculated, maybe the traffic will be growing over the period of time. So we have to keep it in mind that how the bridge is going to behave under external conditions, in terms of the traffic, in terms of the weather, and so on. So the sophisticated health monitoring system is kind of equipped with this bridge particularly. And what are they monitoring? They're monitoring the damage detection part of it, monitoring of the weather conditions, and of course earthquake monitoring as well. And the environmental factors, load factors, and the bridge structural response, which is also measured with this one. Now, there are 104 sensors has been mounted, and around 171 data channels are there. And this data is acquired from the signal processing point of view. And this is almost like on the 24-bit architecture, 1 by 1000 second, the data is coming in continuously, and they are acquired. So the bridge is there, the sensors have been put, and the data is acquired. So now to give you a little idea, this is the bridge, which is like a front view and the sectional view. Different kinds of sensors have been put. There are temperature sensors, there are strain sensors, wind sensors, multi-sensors are there, which can measure everything. There are corrosion sensors, which is when video cameras have been put, and of course the traffic analyzer is there, which can give you an electromagnetic. So these sensors, which has been put on this bridge. So the fundamental question as a civil engineer we need to ask is that, where to put these sensors? How do we choose that location the sensors have to be put? What should be the sensitivity of the sensors? What number of channels I have to put it into that? Because sensors are not so cheap. I'm sure Bridge Division can tell these sensors how much it costs. So it's a huge thing. And that is where actually we need to optimize it, and we have to kind of get the maximum outcome out of the monitoring. So what we require is that this kind of a monitoring really helps in terms of getting the information about the health of the bridge. And these are the different informations like what they measure in terms of like the structural temperature, the strain gauge, the bendable or not, wind speed, earthquake related information is available, corrosion, and of course the cameras which monitor the traffic and so on. Okay. So the having put the sensors on that, it follows exactly the same architecture which we have mentioned. That the sensors have been put on the bridge, the data is transmitted wirelessly to remote server, data is captured. So this is a reality. So we cannot ignore that. This is now happening, and this is where actually the data is acquired, and the kind of the display and on kind of it's like a pilot's cockpit. So you are sitting in an air-conditioned room. The bridge is somewhere else. You are in front of you. You have different cameras which are giving you a different condition at that instance. What kind of a traffic flow is there? Which location it is there? And what are the sensors? You want to see the different information about the different sensors. So you can really visualize what is the temperature, what is the humidity, what is the strain level at different locations, and so on. All these things can be monitored. Now, in fact, from traffic point of view, intelligent transport system IDS, what people are putting up the cameras and viewing it. So there is a nice way of monitoring it. Because some of the times the bridge sensors are giving a certain information, but there is no traffic. Means there is something problem with the sensor, and that is how they can diagnose even the problem with the sensors as well. So this kind of correlation can be figured out by combining two pieces of information simultaneously sitting in that room itself. And this is where actually the user can get a very nice feel of the information. These are the recorded data. Suppose you want to kind of post-process it. You want to see the data later at the end of the day. You can extract the data. You can see them. You can even see them in a continuous way, live view also, how the information is coming. You can also see in terms of the Excel sheets, you want to open a data, you want to just check it out, export the data, you want to extract some part of it and play around with that, that is possible. And of course, at the end of the day, the whole report also can be created generally, that what is the condition of the bridge, different locations, different sensors, and so on. So this is actually the whole documentation, and this report can go to all the concerned authority, and they will have an updated information about the bridge on a particular day, what is the condition, and so on. And this is again, it's a basically encrypted way the information can go. So in a nutshell, what I just want to tell you is that the technologies are existing. It is being implemented. People are use the state-of-the-art knowledge, and they are actually using it not only internationally but in India, and that is an example of it. So coming to my last thing, I just want to close it by mentioning about that the structural design, the analysis and testing, of course the various kinds of the problem areas, which is like a location at which we are monitoring, inspections and so on. And with the first-hand information, we will be able to kind of create the improved reliability, we can increase the performance of the bridge, and of course we can reduce the life cycle cost. These are the possibilities are there when we start using the big data analytics into this one. I just want to mention one more thing is that when I talked about the big data analytics, I did not get into more of an analytics part of it. Because analytics is more of the tools, the methods and techniques which we want to use it. That could be the topic by itself. But just want to give you a little idea that if you know the problem very well, then the tools are just the available off the shelf. You can pick it up. and kind of use it for the purpose. So that is something which it can be used in the health monitoring. Okay, so to just kind of close it with the key challenges, as I said, the first is the data, the second is extracting the information out of it, then going more deeper into it, finding out the knowledge, and then take a decision of it. This is the whole process which one has to follow for the structural health monitoring when you are using the big data analysis. Anyway, I just would like to thank all the internet and a lot of other published papers. I have acknowledged as much as I could from various researchers, some of the things which I have been working, I put them together because I wanted to put with a generic talk rather than getting you more into the technical part of it. So thank you so much for your patience for listening this talk. Thank you for inviting me to CRI. Yeah, no problem. Yes, sir.
I request the attendees for any questions if they have. Now there is a question and answer section. If anyone have the questions, please raise your hand so that mic will come to you. You can ask your question.
I would like to ask.
Any questions from the participants? Yeah.
Thank you very much. Actually, my name is Ashwini Gupta. I'm a PhD scholar in this institute. I just wanted to know that, of course, this big data analytics seem to be very challenging and very interesting for the structural health monitoring. But what I want to ask is that obviously all these times we are already having lots of sensors placed in the bridges and lots of data is being collected. So what difference this big data analytics has made into the structural health monitoring in terms of time, in terms of efficiency, in terms of cost, and in terms of the simplicity or the ease of doing structural health monitoring. So basically, as you said, the analytics is a separate part, and then that's a different subject. But I think this data was as it is being collected. But I think more important is the analytics and how that analytics has really made a change in the entire process. Thank you.
Thank you so much. This helps. See, let me just tell you. I'll just give you a little example first, and then possibly you will be able to appreciate. All of you use Amazon, correct? And you want to buy something, and you go to Amazon. Just imagine a few years back, when you were purchasing something, you were not suggested anything any point of time. But now, if you go to buy something on Amazon, if you're buying an next item, the bottom it says suggestions. It says that somebody who bought this also bought this one. And possibly it would be likelihood that you might also like it. Okay, how it is happening? It is happening because there are tools working behind, analyzing data continuously. Okay, so now coming to your question, so far we have been acquiring the data, but we never kept that tool working on it all the time. Now these techniques and tools and algorithms, architectures, methods are available to us. If we start using that, then it is like every day's information is taken and analyzed in a faster way. And these things are now possible because high performance computers have come, faster algorithms have come, and many methods have come which actually helps us to analyze it very quickly. And that is where the analytics plays a very, very important role. And analytics is just not about using these tools. We need to have a very deeper understanding about the statistics. We need to have a deeper understanding about the various features which this data carries and how they are relevant to us. So we might have data, but we never use it. We never used it. But now this is a time when there are techniques and tools are available. If you plug it into that, we are much faster than what we were there earlier. And the example which I showed you the last case is basically that is an example. That now the data is coming in a real time. Every day evening there is a report is generated from that data. So imagine a sensors, instead of a human being now, the sensors are sending information every day to you. And you are kind of getting, let's say for example, you are monitored every day in, let's say, a patient, somebody is monitored in ICU, let us say. We wait until the doctor comes and he analyzes the data for us. At the end of the day, whatever the information will be, he will spend a couple of minutes with you because he has to visit so many patients. But suppose this data goes into the system and kind of gives you a little qualitative assessment instantly. And that is the now stage it has come that we can actually tell in real time. That is where the big data analytics plays a very, very important. And we talk, big data means I'm talking in terms of the size. Like so many sensors, if there's one or two sensors information, it's okay. But when it's so many data sensors are coming together, you have to kind of integrate them and come up with a solution or rather decision. That is the most interesting. So it is happening. This is a reality. In fact, now there is a new domain totally that has happened in the health monitoring is that the sensors being so expensive. Okay, and monitoring these bridges with so many sensors is very, very costly affair. So the now monitoring happens in another way around. If suppose I mount a sensor on a vehicle and the vehicle passes on the bridge and it will give me the information about the condition of the bridge. So you have to mount only few sensors. And that vehicle can move with a different velocity, different speed, different lane, different weight load, and what bridge is going to behave. That is a very interesting area now, that how I can get. So like for a train, for example, you must have seen the train is having those testing trains, which has all the sensors on that. And the trains are moving on a track and trying to find out the rider's index basically, to find out the comfort level of a passenger. So there the sensors are not put on the railway track. The sensors are in that not wagon, what we call the bogie. The bogie that is the sensors. They are acquiring the data continuously for the complete track. And then based on that they give the information. So the time has come now that we minimize the number of sensors and extract maximum information out. That's where we are heading. I do not know I have answered your question, but okay.
I noticed the cost of monitoring increased due to sensor.
Yeah.
And then people cannot analyze, so they say it's volatile, so don't touch it. Say your manipulation. There is many others. So I was just dreaming if single sensor can serve some purpose, particularly for simple structure. This is all very complex. Say one accelerometer is sufficient to give some information. That's what.
Yeah, so that is what I'm saying. The other way around you will be doing, like if you monitor this through the vehicle, then your number of sensors are reducing. Like for example, in this case, 104 sensors have been put. Suppose the car only moves with the sensor and gives you condition of the bridge. That's the best way of kind of getting. So since in 2000, I had a chance to work with this in the area of the names actually, micro electromechanical system. There's micro sensors included into that. Those days it was like $20 or so. I'm talking about in 2000. And it was not that easily available because people were still working on the sensors. And civil engineers are crazy guys generally. I know them very easily. That they would like to use it in a most adverse condition. So my sensor would sit in a concrete. That itself is a huge thing. The number one, which location I want to monitor the sensor. If I'm putting into the bridge, that's a concrete bridge, the location has to be precisely at that point only the strain has to be measured or acceleration has to be measured. It might get dislocated if I'm while concreting. So I need to package it properly, fix it properly, keep it exactly in the same orientation should be perfect. Even let's say we are putting our strain gauges on external surfaces, we have to be so careful Now imagine something which has to be embedded. So what I'm trying to say, that is where the whole challenges are there. I work with the RFID tags, like, they are used into concrete. So one of the basic application was that the precast elements which are made mini, you put in each precast element when it was manufactured, what was the quality check and all that, people put a barcode, correct? Now this barcode paper can go away anytime. Somebody fill off, somebody goes sits below the bridge, it just goes and fills up that paper, you don't have any information. So there they came out with this RFID tag, embedded into the concrete. And they are passive kind of tags. So it is inside, externally you excite it and you get the ID number and then you plug it into your database and you can find out when it was manufactured, who was on the duty, what was the mix proportioning, what are the material used, where it was manufactured, etc. etc. All the history of that element can be. So when we were doing this exercise of putting an RFID tag into the concrete, we found that almost like 25% of this RFID tag will go. It will not function. And those days I think it was $5. So you can understand that even it's not even a sensor, it is just giving you ID, just a unique number, just give you a unique number. So it's a challenge for civil engineers. It is always a challenge. That's why most of the time people go into more of a maybe composite kind of a structure or steel. Composite is very good because in a composite material you can like gearboxes and all that, you can nicely put them and seal it, or you can put it into the steel surfaces. You can put it very easily. But in a concrete, when you want to put it, it's all more. And the measurement what you are doing is that on surface, within surface, how deeper inside, which location you are doing it. Yeah. Yes.
Hearty compliments to you, sir, for a very nice, excellent presentation. The subject topic is very complicated, but with great simplicity you introduce it. And I think the persons who are exposed to this subject for the first time, they have also get some kind of understanding. That was the quality of your presentation. So our best wishes. And just I wanted to say, the initial, you started with that even Dr. Raychaudhari, means you were born, at that time that reference was there, and now you are delivering the talk. He was also specialized in distance diagnostics. At that time, he was following that non-destructive testing.
Yeah.
And the change in this technology, this is entity to now structural health monitoring. Rightly, you are taking the baton, and what you presented is the state of the art. It is real life structures. We are also having some references, and definitely we may have some, you can say, collaboration. So once again,
Thank you so much. Thank you so much for your warm words. Yeah.
Any other questions?
Any other questions?
Now I request the attendees of MS Teams, if any of the attendees have any questions, they can raise the questions here. Mr. K.M. Venkatramanji, please unmute yourself and raise your question. Please ask your question, sir. Sir.
Am I audible, sir?
Yeah, you are audible, sir. Speak a little louder, please.
Yeah, what are the normal parameters which are monitored in a breach? What are the normal parameters which are monitored for a breach?
No parameters.
parameters which are like direction.
Yeah. So it's yeah. Okay. So the generally are the sensors. What we measure is the accelerometers, the strains, displacements, and temperature, particularly temperature corrosion, particularly, and also the other environmental conditions. Like what is the temperature, what's the humidity outside, and what are the forces are acting, the wind forces, or sometimes even earthquake is monitored for this kind of issues, so on. So these are the parameters we try to monitor.
Okay, thanks.
Thank you.
Thank you, Venkatramanji. Yeah, one of the questions from the chat box is that can a fragility curve be made from the failure data? From where can we access the data?
Since actually I'm not the expert of a fragility area, but one thing I can just say that because we are monitoring the health, we are not talking the failure. So the failure is completely like the forensic investigation. So possibly even the, if you want, I can connect you with the right set of people who can give you the right answer for the fragility. You can just let me know. You can connect. Yeah, I think one of the same question is there from Shivani. She's asking from where can I get the data? So maybe possibly if you have the video data, because she's interested possibly to go for the fragility analysis.
Okay, sir. Thank you, sir. Many more questions are there, are lined up for you, but due to the time constraint, let us take, let us move forward. Thank you, sir, for your thoroughly inspiring perspective on the highly significant topic. We now request Honorable Director CRRI, Professor Satish Chandraji, to kindly felicitate as token of love and gratitude to today's chief guest and esteemed speaker, Sri Sudhir Kumar Barai, Director Brits Pilani, with a memento and a shot. Yes, sir. Now we are moving towards the end of this event. I would like to invite the senior most scientist of our division, Dr. Lakshmi Parmeshwaran, with our immense knowledge and experience, guided us as a strong pillar to organize this wonderful event. I request you, ma'am, to deliver the vote of thanks.
Good morning, everybody. Honorable Chief Guest, Professor Sudhir Kumar Barai, Director Brits Pilani, Respected Director Professor Satish Chandra, and Dr. Mrs. Minati Raychaudhari, Architect Devajani Raychaudhari, my colleagues, friends, students who are present physically here and joined through MS Teams and who are watching through YouTube, ladies and gentlemen. I deem it a great honor and privilege to propose the vote of thanks on behalf of CSIR CRRI to an eminent teacher and prolific researcher of our time. We have just listened an illuminating lecture by Professor Barai on potential of big data analytics in structural health monitoring. Sir, we have been doing structural health monitoring of bridges, both highway bridges and railway bridges, since 90s. And as you said, it is quite challenging, and the type of sensors what you use that has evolved over a period of time, and we collect lot of data. For example, in a railway bridge, we take almost 2 to 3 days for putting the sensors in location, but for the actual testing, we get only 1 or 2 hours because blockage of trains is costs lot of money. So railway authorities give only very short time for collecting the data. But the data processing in a conventional way, it takes 2 to 3 months. So you can just imagine how much time we used to spend in a traditional manner. But I'm sure that your lecture will be will give a new direction to the scientists who are working in the area of structural health monitoring, not only in bridge division, but our pavement division people, they collect pavement distress data using a network survey vehicle, which have been fitted with a lot of sensors, and also traffic engineering people, they collect a lot of traffic data, and also geotechnical engineering people, they collect details about the landslides, etc. So I am sure that it is going to be a turning point to all the scientists who are working in this area. And field data is very, very important. And as you rightly said, unless we use it, it will be a waste. We are fortunate to have you here, sir, for giving us this intellectual treat. We are grateful to you for readily accepting our invitation, gracing this occasion. I would like to express our sincere gratitude on behalf of all of us in CRRI. Thank you very much, sir. We are grateful to Dr. Minati Raychaudhari for instituting this Dr. P. Raychaudhari Memorial Lecture Series at CRRI. Madam, we are indeed delighted to have your presence along with your daughter and grandson on this occasion. Dr. P. Raychaudhari was committed to lifelong learning and believed in knowledge dissemination. This lecture series gives us an opportunity to celebrate the scientific temperament and the team spirit cultivated by him in CRRI, to draw inspiration from his R&D and to strengthen our research and development. The successful culmination of this program owes much to the guidance and support of our esteemed director, Professor Satish Chandra, and we thank you very much, sir. Special thanks are due to Dr. Neelam J. Gupta, Head IIT and her team, Engineer K.K. Jain, Head Maintenance Division and his team, and Sri Madhyapan, Head Computer Center and his team for their efforts in organizing this event. And also thanks are due to Dr. Rajiv Goyal, Head Bridge Engineering Division, Dr. Naveed Kaur, Engineer Durga Prasad, and scientists of Bridge Engineering Division, and all other staff of BES who have worked with lot of enthusiasm in organizing this event, and especially after a gap of online events because of this COVID pandemic. I also thank all the distinguished invitees who are physically present here and also virtually participating through the digital platform, and for accepting our invitation and to be a part of this event. Last but not the least, a big thank you to all my colleagues who have worked for organizing this memorable event. I thank all of you for your presence today. Thank you very much.
Thank you all. Thank you. Thank you.